Hello everyone, welcome to Roman Just Codes. I'm Roman, and in this episode I'll continue building our Flicky Home Automation app. This time we'll be focusing on the devices page, where I can see the added devices, see their details and status, whether they are on or off, as well as perform some straightforward adding and removing of devices through a simple input form. We'll also do validation and start laying down the foundation of our persistence strategy. Make sure to catch the previous videos in this series so you can catch up, or grab the link to the repo from the description for the full project. Let's proceed. We'll flesh out our placeholder devices page we created earlier. Start with a column with its children left aligned. As the first child, let's build a common header from a padding widget enclosing a flex widget with a vertical direction. Again, setting it up that way for my responsive strategy later. Add a flick animated icon for the corresponding page, in our case, the devices icon, followed by a text widget with the proper styling coming from the active theme and the color from the same. Let's apply a sliding animation from the right with a fade-in animation as well. I kind of want to apply this same header to the rest of the pages, so I'll make it into a shared widget I'll call main page header, which will take a string title and a widget as the icon. That way I can pass any widget, whether an icon or my very own flicky icons. Pass the appropriate values for the devices page, then test to make sure it works as before. Nice. Now let's add them to the rest of the pages, the rooms, and settings. Just change the icons and title accordingly. Rooms page header is in place. Let's do the settings now. Good. Let's get back to our devices page and start fleshing out the list of device row items. Replace the spacer by an expanded with a child widget called devices list. This widget will encapsulate a vertically scrollable list of device items. We'll create it in just a minute. Create the model that represents a single device, so create a file called device_model.dart and add the corresponding class. A device model will keep track of a representative icon for the device, a string label, a boolean flag whether it is selected or not, and the ID of the outlet. This is the unique identifier that ties our device to the actual physical smart device we want to talk to and send commands to. We want to enforce immutability in this model, so create a copyWith method. We want to serialize this object as a JSON structure, so create a toJSON method. And last but not least, we want to be able to deserialize it from a JSON structure, so create a fromJSON factory constructor. Let's create a repository that will supply the data for our devices. We'll start with a mock representation, and in later videos, we'll pull this from a stored location like shared preferences or a database. I'll add a method called getListOfDevices, which returns a list of device model instances. Simulate a 2-second delay, fake in some retrieval latency, and return a hard-coded list of device model objects for now. With the repository in place, create a corresponding provider that provides this repository, so add the providers file that encapsulates related providers. I'll call it deviceproviders.dart. Add a simple provider called device repository provider, encapsulating an instance of our newly created devices repository. We need a view model that handles the UI logic for the devices list. I'll call it device list view model. A state notifier that manages a list of device model instances. We'll add a method called initializeState, whose only job is to initialize the list of device models. Back in the device providers file, add a provider that wraps the implementation of this view model. I'll call it device list VM provider. We'll first fetch the list of devices, then we'll feed it into the view model. What's the best place to do this? In the loading sequence of this app, correct, in the view model called loading notification view model. Now that I'm here, let me fix the way the messages get displayed. I truly want every message to slide in as they change, not just at the beginning. In order to force each message to have its own animation, I must force it to rebuild as the message changes. For that, we'll use a value key object, feeding into it the loading message and assigning it to the key property, which is different from message to message. That will tell Flutter that this widget is completely different, hence forcing it to rebuild as the message changes. Value keys are great for this purpose. For example, if you have a stateful widget which you truly want to wipe out its state and rebuild from scratch. Let's go to the loading notification view model file. Remember we did some placeholder waiting simulations? Now it's time to replace them with the actual data retrieval and logic. At the point where we show the loading device list message, we'll do a fetch for the list of devices, pulling from the corresponding provider as such. Once you've obtained the list, feed it into the device list VM provider via its initialize state method, so this view model caches it up front and manages this list. Some sort of lazy loading strategy we get from Riverpod for free. Start a quick debug session to ensure you're getting the right values and injecting them appropriately. There they are, our two mocked device model instances. We're cooking, y'all. Let's continue fleshing out the devices list widget. Make it into a consumer widget so we can use the provided widget ref to read the corresponding provider and get the list of devices. Check whether the device list is empty, and if not, render it as a scrollable list using the list view builder widget. Add a text widget to display the label for now. Otherwise, show it as a warning message. I'll build it as a center widget wrapping a column with a warning icon on top and a label below showing a relevant warning message. Add styles and colors from the theme accordingly. And add some flair to it by adding a vertical sliding animation along with a subtle fading transition. Test by returning an empty list from the repository to trigger the warning message. I kinda like this warning message. Let's extract it into its own shared widget called warning message, shall we? Just make it into a stateless widget, passing a string message into it, plain and simple. Hey, let's reuse our newly created warning message widget on all other pages. Why not? Back on our devices list widget, let's replace our placeholder text widget for the actual implementation. We'll create a widget called device row item, which takes the device instance and renders it as a separate row in a list view with an icon and a label with tapping capabilities. Create its corresponding file, do the usual import and cleanup. Let's focus on the device row item widget. Reuse this container and add some margin. Lay it out as a row with some padding around it, and as its children, a flicky animated icon using the device's icon option property and the isSelected property. This will drive the logic of whether the icon is animating or not as the user toggles it. Add a small gap in between to give it space to breathe. Use an expanded widget wrapping a text widget to show the device's label. Add a text style that fits your needs and add the logic of showing the appropriate color from the theme whether the device is selected or not. I'll move this logic above. I might be reusing some of these values later. The background color and splash color will also be driven from the logic above, depending on whether the device row is selected or not. Wrap the inner widget inside an inkwell to leverage both on tap event and the ink effect. Don't forget to add a material widget above it. Let's do some clipping and border radius to give it a smooth look. Hook up the OnTap device events applied and feed the device instance to it. Making great progress. Let's test the toggling capabilities of this component. I'll create a method called toggleDevice in the device list view model. All it does is toggle the isSelected boolean flag to whichever device is matched from the list, updating the state to trigger a widget rebuild. In the OnTap device event, just invoke this method out of the device list VM provider instance through its notifier as such. Check it out, the row gets selected as expected, and the icons show animated. Nice touch. Let's now work on the device details page, the page that we will navigate to when we tap on this device row. This page will be used for both as an independent page and in a master detail layout on larger screens for our responsive strategy. Let's flesh it out. Create a new page under our devices feature called Device Details Page. Create the corresponding file for it. Add a route to it so we can navigate to it using the GoRouter package. Since this will be a full-fledged page, add a scaffold as the root widget with an app bar so we can leverage the back navigation since we'll be pushing it onto the navigator stack. Add a GoRouter entry for this newly created page at the root of the navigation, parallel to the shell route, since we want this page to take users out of the nested navigation. In the device list view model, add a method called showDeviceDetails. From inside this method, we'll navigate the users to the device details page. Do this for now. We'll come back and finish it up. Back on our device list widget, instead of toggling the device from here, we'll instead navigate the users to the device details page. Replace the toggle device by the show device details, passing the selected device. Let's test that we can navigate to it successfully. Cool, things are wired up nicely. We need to somehow capture the information of the selected device without passing it from page to page. Instead, we'll use a mechanism to hold it in memory while we perform the navigation. For that, we'll use a state provider instance. In your device providers file, create a state provider called selected device provider. This will hold for us the currently tapped device from the list while we make the navigation, and we will use it to fetch it from the other end. We'll make it nullable for our future master detail implementation. You'll see why in later videos. Bear with me for now. Right in the show device details, grab a reference to this state provider and capture the selected device model instance and hold on to it. Let's continue fleshing out the device details page. And to make the contents of the device details more reusable and to support our master detail strategy later, we'll encapsulate all this logic yet as a separate widget called Device Details Panel. This page is only serving as a page wrapper for this widget, so it behaves like a full-fledged page and can be navigated to, but can be used as an independent widget as well. Add the corresponding file for it. You know the drill, make it into a consumer widget, well, you know why. To read the device we just selected from the state provider called selected device provider. So, if the device instance is null, you can display a more appropriate message. I want to show a widget made up of a column with a bold icon, a text widget that says select device, with the proper text and color styling from the corresponding theme. I see myself using the color and text theme quite a bit here. I'll extract it as a property so I can reuse it throughout. Capture the selection color depending on the device's isSelected flag and show a color accordingly. For now, I'll make it simple. I'll lay it out vertically and centered with a flicky animated icon from the device's icon option property, followed by the device's label with the appropriate styling color driven by the properties set above. Take it for a spin. Yes, this is expected, as the device data is null as no one has selected anything in the previous screen. See, now the device details page shows the corresponding information based on the selected device from the previous page and in a decoupled way. Let's continue. Add yet another column above it since I want this content to be on top, with a toggle widget at the bottom. Inside an expanded widget with the flex property set to 2, so it takes twice the space in the column. The toggle widget below will be nothing more than an icon widget driven by the logic of whether the selected device is selected as well as the selection color above, and wrapped inside a gesture detector to give it tapping capabilities. Here's where we'll test the actual toggling of the device's metadata. Take it for a spin and tap on the toggle icon. Something's wrong. I'm tapping it, but nothing happens. However, when I go back to the device list page, I see it selected. But then if I come back in, then is when I see it selected. This is weird. No, this is by design. It's because we are not updating the selected device state provider. We are watching for changes on it, but the toggling method is not updating it accordingly, only when we tap on the row and not on the toggle icon. Let's fix that. We're watching the selected device provider. All we have to do is update the state provider as we toggle it in the device list VM provider. This will trigger a rebuild on this widget, thus showing its updated state. After toggling it, you can do something like grabbing the one from the state that matches the incoming one in label and outlet, since there may be more than one selected at the moment. And update the selected device provider with it, simple as that. I'll make sure outlets have a unique ID, of course. And there it is. As you toggle, the widget rebuilds, reflecting its current state. Flawless. Let's continue building up on this panel. Add more padding around the whole column, center it on the whole page, and add an outer container with the proper decoration so we can change the background depending on whether the device is selected or not, with a nice border radius to stay true to the aesthetics of this app. Looking good, I might add. Animate the entrance of the items in the column so they don't look so stiff as we transition into this page. Do the usual vertical sliding transition paired up with a fade in. This list looks so static. Let's also animate the entrance of the items in the list. Come on, animations are cheap. Well, they can actually take a toll on your application if you don't implement it correctly, but thanks to the Flutter Animate package, it makes animating things in Flutter such a breeze. To each device row item in the list view, tack on the animate method using a delay using its corresponding index in the iteration and an arbitrary value so as to achieve a staggered animation effect. Add a slide Y and a fade in as usual, and take it for a spin. Wait, let's add a few more. so we can truly appreciate the entrance effect. And so it doesn't look so bare. Wow, I couldn't have asked for a better, elegant, smooth, yet simple transition as the device row items roll in. Give yourself a pat in the back. With this, we just wrapped up part 1 of this video. Didn't want to make it too long so you can digest it better and appreciate all the work we did in this chunk of time. Catch you up on the flip side for part 2 of this adding, removing, and managing of your smart devices data in Flutter. See you on the next video. Hey there, I am Roman from Roman Just Codes. I hope that you found the content of this video very useful, and if you did, make sure to like it and subscribe to this channel. You know subscribing to this channel is free, right? Thank you so much for watching.